Good morning, students.
Good morning, sir.
Okay. So tertiary. Right. So in the last class, we finished talking about the 1.5. Right. So most of the components in the 1.5, except for tertiary and quaternary fossils, that we need to continue with, so that we can connect this to the unit 1.6. So let's begin there. So let me first of all give you an idea about classification related to different timelines. Okay, geological timelines, and a bit of a terminology related to that we are going to focus on. Then we are going to briefly talk about what is tertiary period and quaternary period, and why are we studying only specific areas in our geological time scale, although there are many of the other areas that you notice there. But the reason behind studying tertiary and quaternary, and here our focus is on the fossils, those that are not living today, because in the major primate classification we focused on living primate classification. We talked about lemurs, tarsiers, right? We talked about old world monkeys, new world monkeys. These are the living examples of primates. But there are many primates which got extincted over a period of time. So our focus will be to look at these fossils that were found in the quaternary period in a particular era, and also in the tertiary period. All 1.6 deals with the quaternary period, so more human-like. We focus on 1.6. In 1.5, we are focusing on more primates, different. They're probably like a bridge between humans and the more classical primates. Okay, in the classification, if you remember, lot of features were primitive in several monkeys, and slowly evolution had happened over millions of years ago to get where we are today. So our focus will be initially to help you understand about this timeline. Okay, and then explain briefly about tertiary fossils. A lot of factual data will be there here. I'll provide you the overall structure and idea about this and the content for you to read. And the exam point of view also, we are not getting specific questions on this part. So even if keeping in mind the time and the amount of information that we have to process, so I'll provide you the structure and overall idea about that. And I'll focus more on the questions that are more frequently coming in the exam, like short notes are being asked on specific ones from the unit 1.6. So features, certain aspects of culture, we are going to focus on them. So for that, let me actually give you a few idea of questions that have come in the exam, so you know where we should focus and what is the reason behind in focusing on some of these things. Like in the unit 1.5 part, if you see, the questions were like this, like explain the skeletal changes due to erect posture and their implications. So the question, we discussed these components, what are the skeletal changes that happened in us, okay, in order to support the concept of erect posture, basically bipedalism and standing upright. What features, what skeletal changes have happened in the last class and the class before? We discussed from the skull to the feet, we discussed various changes that have happened in us. You have to describe them. And next, elucidate skeletal differences between humans and chimpanzees. We also discussed this, right? Compare the skeletal differences between chimpanzees and humans. We also briefly talked about them. And role of primatology in anthropological studies. Why do we study primates in anthropology? Okay, I'm going to provide you. There is a small description I found on this when I was going through an article, but I'm going to provide you just to add a little bit of emphasis on this component. Let me pull that for you. So behavior we discussed yesterday, right? And taxonomy. Okay. Sample behavior factors. Okay, I don't know whether I pasted it, but I'm going to send you that. Okay, so basically, I'm going to give you a brief summary on what is the importance of primatology in anthropological studies. Okay, I saved that paragraph, but I don't seem to find it here. But I'm going to send you that. Okay, I kind of already discussed with you, but a brief write-up on that. Few points, like what is the importance of this primate studies in anthropology in understanding humans. Okay, otherwise, what else you need? You see, man is a primate. Discuss. So why do you say man is a primate? What is the basis for placing man under primates? So what do you need to talk under this? So if the question comes like this, is man is a primate, discuss. Why do you consider humans as primates?
So we can talk about the similarities man has with other primates like chimpanzees, monkeys.
Basically, you discuss the features. So what is a primate? Do humans show those primate features? So what do you do? Various things in primates, like starting with the change in the smell, vision, and the skeletal changes. You discuss them. And do we find all these features in humans? We do. So humans, being that they share these features of the primate, human is placed in the primate order, right? You have to discuss it. So more or less same information you have to represent in a different way. Skeletal differences, characteristics of primates, why man is a primate, all surround the same information that we discussed in the last two classes. Okay, I have seen one document where it said why man is a primate. I'm going to share that. It looks a bit informal, but they talk about specific features. So you get the idea about organizing the answer to the exam that came. Compare and contrast the skull of gorilla and man. So chimpanzees, gorillas. I think we compared both of them, right? Chimpanzees and gorillas. Even for that, I have a couple of images. I'm going to just uh, save a few images like that, share a document, so you get an idea about how to draw the simple diagram and simple comparison. One image or table shows the comparison between chimpanzees and humans, chimpanzees and gorilla. Because at times we have so much of information, what to specify may become a bit difficult. So to help you with that, I collected some tables and images. I'm going to share that with you, either in a Word document or individual images. Okay, so gorillas and chimpanzee comparison with humans is important. Man primate characteristics are important. Changes in skeletal system is important. Same thing once it came in 2010. What are the major craniofacial changes? Major craniofacial changes. okay, in the cranium, in the face that occur during hominid evolution. We also discussed that in yesterday's class in human factors in human evolution. So changes in the skull, changes in the facial part, so that we can accommodate the type of requirement that we have, bigger brains, more flatter faces. We talked about those features in comparison with the apes. Okay, we have to just emphasize on that. Okay. Same thing question again came, like list the major skeletal modifications in humans due to exception of erect posture. This seems to be a repeated question. In factors in human evolution, erect posture, skeletal modifications, bipedalism. Seems to be a repeated question in the exam. Plus comparison between chimpanzees, gorillas, and humans. Okay, so in primate, this is what they're asking. No primate classification we have seen so far, and nothing specifically on tertiary fossils, nothing specifically on 1.5 quaternary fossil component, but in 1.6. So the question seems to be very, very selective. Okay, right. So yes, I think this is what about 1.5. Let me 1.6. They're asking short notes on various things: Homo erectus, Rhodesian man, Australopithecines, Neanderthal man. Okay, so questions are mostly asked on specific features, short notes on those topics that are given in the 1.6. So it is more factual data and being able to connect how evolution has happened. Who are our ancestors? How are they different from us? What features have changed? So these questions that we have to ask. So do you see, understand the demand of these topics, these units, 1.5 and 1.6? So first of all, of course, to provide you an idea, I would like to talk to you about tertiary and quaternary fossils from the 1.5. That brings us to the 1.6. So let me start first of all explaining you terms related to the geological time scale. Okay, understand the concept here. I have tables, simple tables, and the charts that I'm going to show you here. And I'm also going to provide you reading on this, nice summary of what I'm going to explain you here. So we also have content on that, but I'm going to share with you. Okay, right. So let's start with the tertiary. So share the screen with you. So let's learn what is tertiary, what is quaternary, what type of terms do we require here. Okay. Tertiary and quaternary periods. So this is part of 1.5, as I was telling you. It's a bridge between 1.5 and 1.6. Okay. So few terms that we need to understand how life had happened on Earth. Okay, approximately, they say Earth has formed about 4.5 billion years ago. The formation of Earth is dated approximately to 4.5 billion years. And life must have formed about a billion year later, maybe 3.5 billion years, beginning that probably life had begun with very, very simple organisms, like something like single cellular organisms. In a very, very simple form, this life probably had started. Okay. So how there are different eras that you notice here. So you can divide the whole timeline since the beginning of life to today into multiple eras. How do they go with? So you see that the previous era, before these particular eras that we are going to talk, is called Precambrian era. Precambrian period or Precambrian era, which went from 4,600 million years to 590 million years. We normally use the words million years ago or M/A, million years ago. We go backwards from today. 100 million years ago, 500 million years ago. We'll talk about like that. So M/A is a unit that we normally use, which refers to million years ago. Okay. So 4,600 million to 590 million years ago, where the Precambrian era was existing. After which, after Precambrian era, you notice that we actually have three eras that we put into, like Paleozoic era, Mesozoic era, and Cenozoic era. So the modern era that we are in today is Cenozoic era. The previous era to Cenozoic is Mesozoic, and before that was Paleozoic. So Precambrian, Paleozoic, Mesozoic, and Cenozoic. So we divided them into different periods in a way. Of course, period is a different word here. Era. So in its literally sense, if I have to say, this is a period. This is an area, the time scale, where certain events have taken place. I'll tell you what they are. Sometimes you even hear the words in Precambrian era. Sometimes you even hear. Let me type that here. So era is a kind of a bigger unit, bigger chunk of time. Okay. So sometimes you also hear these two eras as part of Precambrian era. Archaeozoic era, and also you will find Proterozoic era. Proterozoic era. So as part of Precambrian era, sometimes you also hear the terms Archaeozoic era and Proterozoic era. Proterozoic. As part of the Precambrian era. Okay, on the geological time scale. Okay. So what had happened over a period of time? What is this image showing? So life probably had begun somewhere here. Single cellular microorganisms. They probably had started showing up 3.5 billion years ago approximately. About 3.5 billion years ago, life might have started. Okay, approximately what we said, 4,600 million or 4.6 billion years ago. We started seeing formation of various components on the Earth. Okay, and various planets. So those things might have happened there when Earth actually originated. But it took almost a billion years of time to show life, existence of Earth. So about 3.5 billion years ago, approximately, we started seeing single cellular microorganisms have formed. Single-celled microorganisms have formed. This is probably the first sign of life as far as our understanding goes. So this happened at the end of Precambrian era. So especially in the Proterozoic era, where you probably have seen small early forms of life. Early forms of life. Later came the Paleozoic era. So Paleozoic era falls between 590 million years to 250 million years ago. As I was telling you, we go backward here. 590 to 250 million years. Okay. So what happened here? Here different life forms, bit more complex and more advanced life forms have happened in the Paleozoic era. So life continued to happen. And the new varieties of life started to kind of explode. Okay. So we started seeing different types of creatures, other forms of creatures started happening in the Paleozoic era. Paleo normally refers to old. Paleoanthropology we talked about, right? With the word we use paleo referring to old life in a way. Old life. Okay. And here some more life forms started showing up, like several protozoans and snails, etc. started showing up here. And from Paleozoic era, we move to the Mesozoic era. Mesozoic era. Meso means middle or intermediate. Paleo means old. Meso means middle, intermediate. Okay. So Mesozoic era, what had happened in Mesozoic era, for example, if you see this went from 250 million years to 65 million years. It went from 250 million years to 65 were the most common ones that we have seen in Mesozoic era. In Mesozoic era, several reptiles got formed. Okay, dinosaurs got evolved. So this was the era where big animals started showing up, starting from very simple creatures to bigger and more complex animals showed up in Mesozoic era. They existed, they continue to exist, but new life forms have been created. Okay, and then came the Cenozoic era, starting with the 65 million years to current time. So we are in the Cenozoic era today. So we are in the Cenozoic era. So what happened before this, between Cenozoic and Mesozoic era, mass extinction event has taken place. Approximately 65 million years ago, mass extinction has taken place. So this is where I think dinosaurs got extincted. So we noticed that dinosaurs got extincted during this period. And during the Mesozoic era, along with dinosaurs, there were some mammals that were living. I think this was last Sunday or before Sunday, this came in the newspaper, that some mammals existed along with the dinosaurs. Okay. And what happened once the dinosaurs died, they got a new place to survive. They could explore the new places. They went there and started, explored in a way. New forms of mammals started showing up. They say radiation. We talked about speciation. We talked about specific form of speciation, right? So in which we notice that they go in various dimensions and various forms of mammals, got evolved. So this is the period in the Cenozoic era, beginning of the Cenozoic era, where it seemed to have happened. Mammals started dominating because dinosaurs are gone. They got new places, new habitats to survive. They started surviving better. Okay, and eventually primates and humans, we all came in the Cenozoic era in the last 65 million years. Okay, are you getting the idea here? This is a brief timeline about what are the various eras. We talked about Precambrian, which can be divided further into Archaeozoic and Proterozoic, and Paleozoic era, Mesozoic era, and Cenozoic era. There are particular timelines here. For Precambrian, we talked about approximately 4.6 billion years to 590 million years. And up to 590 to 250 here, and 250 to 65 here, 65 to today. So there is no specific, period, no specific spacing here. Okay, but there is a random timing based on what existed and what are the climate conditions, etc. And you also notice that during these periods, I remember in one resource I was looking into, there were a lot of changes in how continents were arranged. So tectonics, I don't know if you study this in archaeology. So because of the movements in the plates or layers of the earth, what happened? The earth didn't have the same shape. There were some continents together at one point of time, and these continents moved away at one point of time. So the location or the geographical positioning of these organisms, and also the connection, whether they could travel from one side to the other side. India was separated at one point of time before it was joined with the other parts of Asia, right? So a lot of factors have changed. Conditions have changed. They said there was a very, very warm climate before, and that warm climate slowly cooled down. So certain creatures could survive in warm climates, and they could not sustain the changes that were happening in the climatic conditions. They got extincted. Like that, many life forms have come and gone. And today we are only seeing a very, very small percentage of life forms. And of course, in anthropology, we are more interested in this part. We are more interested in this area where humans have come, where primates have come, and from them, humans today, from apes and other monkeys, humans got evolved. So our focus is on this, but a brief idea over what else was there. Okay, we have a good physical anthropology chapter on this where it nicely talks about this overall evolution. But for the exam point of view, this is sufficient. We don't need to know more details than this. Okay, but if you are interested, bit more explanation to what happened in Paleozoic era, Mesozoic era, Cenozoic era. I'm going to provide you like a paragraph and of information. This is given in a chapter. Okay, right. So let's focus on Cenozoic era. And let me introduce few more terms. So far we talked about eras. And eras are further divided into periods. Eras are further classified into periods, and periods are further classified into epochs. Epochs. So in a way, if you can remember, epochs, EP is epoch. E is era, P is period, EP is epoch. So remember, the era is a bigger unit, Period is the next bigger unit. Epoch is the third bigger. Okay. So let's see what are the different periods and epochs. Some more terms that we need to check here. Here I just showed you the different categories: eras, periods, and epochs. Okay. Let me show you this nice image which talks about, just adds the information to what we already discussed. Like eras we talked about, right? Look at the on the x-axis. What are we seeing here? We are seeing eras here. Are you able to read the terms, or do you want me to enlarge it? Are you able to see this image? Is it clear enough, or
I can read it, sir.
okay? If otherwise, I can zoom it. If you are able to see, this is great.
So please zoom it.
Sure. Okay, so what are we talking about here? Here we are talking about eras on left side and the middle periods and epochs. This image gives us the overall picture about terms that we require for understanding this geological time scale. Okay, so let's start here. So era, upward, if you see Precambrian era that we talked about, 4.6 billion years ago. Look at this. Some simple life forms have formed at that time. Okay, so 4.6, 2000, 1000 million years, like that, few life forms have formed. Then came the Paleozoic era we talked about. Okay, I'll share this a table of this. So don't worry, you don't have to write or by heart these terms for now. So Paleozoic is of not too much of interest, but there are different periods. So as I was telling you, the second middle column is periods. There were many periods: Cambrian, Ordovician, Silurian, Denovian. So these type of periods were part of the old period, the Paleozoic period that we talked about. Okay, where other life forms have slowly showed up, and eventually leading to Mesozoic era, where we talked about life forms like dinosaurs have originated. Yeah, this Mesozoic era is further classified into Triassic era, Jurassic era, and Cretaceous era. Okay, so not era, periods. Triassic period, Jurassic period, and Cretaceous period. Basically, different forms of lives have happened here. Okay, within this, we're talking about 200 million years ago, 100 million years ago, like that. Okay, this is also not something that we are more interested in. Our interest is on the further. Okay, so Cainozoic, or it is also called Cenozoic era, as I was telling. Cenozoic refers to new life. The current era, as I was telling you, is Cenozoic era. So Cenozoic, Cenozoic, or it is also called Cainozoic era. Okay, this is where our interest lies. So here there are two periods within it. What are the? Tertiary period and quaternary period. In the syllabus, if you see what they say, study about tertiary fossils, study about quaternary fossils. This is where primates have evolved. So our interest in tertiary and quaternary is where primates have evolved. Okay, and within tertiary, there are several epochs. So these are the subcategories of the timelines. So tertiary period is further divided into these many timelines that we are seeing. So what are the timelines here that we are seeing? Paleocene, Eocene, Oligocene, Miocene, Pliocene, and Pleistocene. So these are all the different epochs. This you have to make a note of. Okay, tertiary, put tertiary and put arrow marks and write down briefly this: Paleo, Eo, Oligo, Mio, Pliocene. I'm going to use and briefly tell you examples of fossils that survived in that time. So to finish the 1.5, I briefly need to tell you about some examples of creatures, primates that survived during this time through fossil studies. So what do you write? Tertiary is categorized into several epochs. What are they? Paleocene, Eocene, write down these things: Oligo, Mio, Plio, and Pleistocene. You will eventually get used to it. In the exam point of view, we don't need it, but in the syllabus, this is given, so we need to briefly learn it. Paleo, Eo, Oligo, Mio, Plio, and Pleistocene.
The Pleistocene comes under tertiary.
Yes, color. Look at the color version. So they all come under these. There is little confusion about what goes where. A bit of confusion is there. Okay. So towards the end, I'll explain that what is the confusion, but for now, write down these terms because you will see the color of it. Okay. So here, usually in the literature, I notice that after Pliocene, like Pleistocene, Holocene, usually put it to the Quaternary period. I think I probably have another slide for this. Doubt that. Yeah. So up to Pliocene, Tertiary, Pleisto, Holocene comes under Quaternary. Little confusion about because they normally say they cannot separate them. They call Plio-Pleistocene. They sometimes call it together. Little problem in demarcation here, but otherwise write down Tertiary up to Pliocene and Quaternary, Pleistocene and Holocene. And these epochs mostly defined based on the life forms, what type of life has existed at that given time. Okay. So next 1.6 will focus on Quaternary, Eocene and Holocene. Holocene is the most current. This is where we are today. Holocene is the most current, whereas Pleistocene is the one before Holocene. So the current epoch is the Holocene epoch. And they say that after I think 11,000 years, since last 11,000 years, we are in the Holocene. Before 11,000 years, it was Pleistocene. You see approximately the timelines in millions of years. 65, 53, 37, 26, 12. So I'll provide you a table for this, for the factual information of what million years to what million years. But for now, just remember there are these specific epochs as part of the tertiary period and as part of the quaternary period. Okay. So next we'll talk about so what was there during this time, because the syllabus expects us to learn about the fossils that survived or that were present in tertiary period. So fossils, tertiary fossils, fossils from the tertiary period. So mostly were primates, different primates that have existed, but they later got extincted. So what are those primates? What are the signs of them? What type of evidences that we have? Fossil evidences that we have. So this is partly the concept of archaeology that we study here. So those unearthed fossils, and what did we derive from those fossils, and how did we connect them to this? Lot of basics related to that, like how do we date them, how do we analyze them, right? Various types of studies. You probably have studied, I think, because archaeology classes, I think, more or less are done, right? So you have some idea related to that. So here we are focusing on the result of those studies. Like what do we know about primates during these periods? A brief idea, but this is very factual. I want you to remember one thing for this is we are seeing gradual evolution. So from mammals to primates, there must be certain features that got adapted, right? So what we already discussed about primate characteristics. So when did these arise? What characteristics that we have today were present in some of these primates? So we are trying to look into information, factual information related to that here. For that, there is one document that I'm going to use here. I'm going to share with you that. Okay, so this is EPG Patashala's material on this. So it is under human origin and evolution. Here they talked about early primate evolution, under which they talked about fossil primates. Primates of different eras, Paleocene, Eocene, Oligocene, Miocene, we talked about. But this is, remember, factual data of what is available to us, what evidences that we have. But you will see general trend of becoming more ape-like, more human-like features in these features. Okay, so like fossil primates, they normally put so the living primates that we already talked about in classification, we focused on prosimians, various types of monkeys, old world, new world monkeys, apes, and humans. Correct? So these are all examples of the living primates. But there were other fossils that existed before them. So what are they? So I was also telling you the era that we are talking about where mammals adaptively radiated, meaning they went in different directions, got adapted, and started showing some differences. And eventually they became new species as well. Okay, but we all had a common ancestor. In phylogenetic studies, I'm going to show you briefly that we had a common ancestor from whom we slowly diverged. Okay, giving rise to this much amount of diversity we are seeing today. Okay, and most of the paleontological record, so fossil evidences that we have today related to evolutionary processes, they have occurred in 65 to 80 million years. What era is 65 to 80 million approximately? In what era we are talking about? The Cenozoic era we are talking about, beginning 65 million, so approximately before that, about 80 million years to 65. This is where we started seeing the records of primates. Okay, eventually, so we started seeing various other clues related to that. Like for example, Cenozoic era had shown age of dinosaurs and the beginning of age of mammals. So eventually what happened from them, those mammals, primates started showing up. I was already telling you that Cenozoic era was classified into Paleo, Eo, Oligo, Mio, Plio, and Pleistocene, etc. and Holocene, okay, Tertiary and Quaternary areas. So, and this is where the Cenozoic era, when as I was telling you, primates appeared and started radiating, meaning diversifying basically. Okay, so within the, if you see the earliest primates of Paleocene epoch, in the Paleocene, Cenozoic era, in Paleocene, what we have seen was prosimians. Very primitive monkeys have shown up. Very primitive monkeys have shown up in the Cenozoic era, okay, and especially in the Paleocene epoch. So life, primate-like life had begun there. During the Eocene epoch, we started seeing lemurs, tarsiers. So these type of living forms have shown up in the Eocene epoch. So prosimians, lemurs, and tarsiers, and especially where they were found mostly in the North America and parts of Europe and Asia, is where their presence has been noticed. But what happened over a period of time? They started decreasing. They could not adapt very well to the conditions, environmental conditions. So what happened here in the forthcoming periods? Prosimian forms led to the development of what is called platyrrhine monkeys that we talked about. Platyrrhini, qauternary we talked about it, old world monkeys and new world monkeys. So eventually from these old primitive type of monkeys, old world, new world monkeys have originated in the further periods. So like that, primates slowly evolved within the Cenozoic era after following the dinosaurs extinction and explosion of mammals. That is what happened here. Okay. And finally, as I was telling you, qauternary monkeys, monkeys, it should say, and apes and humans have slowly evolved from the old world monkeys. This is what we see. Okay. So the geological time scale we already covered. So there are many theories. We don't have a clear understanding about how these were originated. There were different theories. Some people said, or Fred Zale in 1972 proposed that arboreal theory of primate origins. Okay, they slowly started adapting to the arboreal conditions. Mammals that were surviving on the trees eventually gave rise to the primate forms of the arboreal ones, those that survived on the trees, because we saw the features of them. So some theories say that we probably came from the mammals which survived on the trees. So this theory is called arboreal theory of primate origin. Okay, but of course that could not satisfy all the requirements. And then alternative idea on primate origins have come in 1992. Other theories have been proposed to explain how primates got originated. Here, they focused on the visual predation theory. Need for standing up, need for better vision for hunting. They focused on this aspect to explain why primates originated and why those characteristics started showing up in the primates. But of course, it also could not satisfy the requirements. So later they proposed so many theories further on. Okay, just wanted to give a brief idea. We don't need to learn about these theories, but no, there are many attempts have been made to explain how primates got originated. We have some ideas, but we don't have concrete evidences to completely explain it. So we come with ideas because in the problem with fossil studies is lot of gaps. We don't have every information that we need. We have to survive with or deal with what information is available to us, what fossils are available to us. So most of the times in this part, we only see bits and pieces of information. To the best of our knowledge, we try to integrate it, but there are many alternate ways of explaining it. Are you following it? The problem with this fossil studies is we only have few fossils that are available to us. Sometimes not whole body, maybe a part of the body, maybe skull is available to us. So mostly what we hear is the facial features. What we hear is the dental features. That is because we only have fossils to support that concept. We don't have the fossils explaining the remaining parts of the body. So we have several gaps in our understanding. So what we are getting is an average picture with what we best could integrate. But we don't have a complete picture about these things that we have to accept. Okay, and many theories attempted to explain why primates have originated like that. But our focus as per the syllabus is on understanding the what fossils were existing. What fossils were existing. Okay, so let's go with this. So they use information that comes from different strata, right? So layers of the earth and what existed where. And if they go underneath the layers, much deeper, it means they are older, right? Archaeology works based on this. So they go with the layers. Most bottommost layers would reflect the oldest versions. Like that, we see more modern versions. That is how they normally go with stratigraphic studies they normally make. These are the evidences that we normally use for approximate time. So there were specific primate fossils that we have to talk about here. So pre-Pleistocene epoch, for example. Okay, so there were many deposits of these that were present. We're going to talk about some of these as related to some of these epochs. Like for example, Paleocene epoch. They say that in Paleocene, it was very, very warm. Warm climatic conditions were there. And most of the inhabitants that we see were found in North America and Europe. Studies have pointed out that the conditions were warm in Paleocene era. Okay, I'm sorry, Paleocene epoch. And especially we started noticing some dominant forms of this in North America and Europe. And mountain regions started showing up in North America, France. And this is where majority of the fossil evidences that we have related to Paleocene times. Most of the evidences that we have are found in the mountain regions of North America and France. Okay, so based on this fossil remains, I'm going to share this with you. Okay, get the idea. As I was saying, this is factual data. We have to gradually understand what was happening here. Don't have to by heart anything for the exam. Okay, so there were a lot of fossil evidences that we got from these areas, especially from North America and France. Okay, so based on this information, what did we find out? We probably have found some early evidences or fossil evidences for the earliest primates that could have formed in this era. Okay, in the Paleocene era, we have seen the initial evidences for primates. Okay, so where appearance of small and primitive insectivorous mammals, they have noticed a mammal, insect-eating mammal called Purgatoris ceratops. Okay, some of these are specifically named in the history. Okay, so they found in Paleocene era, or Paleocene epoch, appearance of small and primitive insectivorous mammals they have found. Okay, and they found single lower molar teeth. They only found the molar teeth of this initially. Okay, so what they have is slight comparison in the dentition component. Later, they found other primitive primates which were placed into a specific class or specific infraorder called Placiarda, Placiardipiformis. They say Placiardipiformis. So they found few other initial primates which they put under infraorder. We briefly talked about this classification, right? Order, infraorder, superfamily, family. Okay, so like that, this is put under infraorder. So within this, there are three major families. Within the Placiarda apiformis, there were three families. Okay, they go with Carpolestidae, they go with Phinacolemuridae, and Plesiardipidae. Plesiardipidae. Okay, so these are the names of families that were put under this first category of primates. On the basis of fossil evidences, okay, this mostly was found in North America and Europe, like France, we talked about, right? This is where the evidences were found, as I was already mentioning to you. Okay, they have certain typical features like jaws, maxillas, mandibles. So basically, skull, parts of the skull that they have found here. Okay, mandible region, maxilla region, and the jaws they found in this, and teeth. These are the fossil evidences they found. So mostly facial features, as I was telling you. Okay. So within them, within these three families, they thought this Phinacolemuridae may be the earliest form of the primates. The oldest of all these things, they thought probably the Phinacolemuridae could be the oldest form of this. But there are not enough fossil evidences related to that. So unfortunately, this is still not very concrete. Okay. So within them, out of these three families, as I was telling you, Phinacolemuridae is what could be the oldest. And what we know more about is the Placiardipidae. So within them, we have a bit of an idea, a bit of more understanding about Placidiapidae. Okay. So because they have complete fossil skull and other parts of the skeletons were obtained from it. So we have better information, resources to learn about it. And what they found from this, that clearly they see that they didn't have stereoscopic vision. So we're talking about early primates, and as primates we have stereoscopic vision, frontation of the eyes, and we understand better depth. Correct? That was absent in them. So meaning they're more primitive definitely than several of the other animals, primates, which have frontation of the eyes. So one feature they found out here that they have stereoscopic vision. They don't have stereoscopic vision yet. It has not developed yet. Okay. And they also noticed dental formula for both upper and lower jaws, indicating that a reduction from the basic dental formula. Some change towards the primates had happened. 2133. I was telling you, if you take 1/4 of the dentition pattern, we normally say how many premolars, how many molars, how many canines. Okay, so we basically number them. Remember, I was showing you in one of the classes, one of the previous classes, where we write this pattern. Right, one of the document I shared with you talks about it. So dental formula has slightly changed. From 2133 it went to 3143. Slight remodification to the dentition, meaning their diet, their survivability was different. So like that, we have some clues related to them, especially with respect to the Plesiardiformes. Okay, right. So some people said they look too primitive to be placed under primates. So there's still debate going on whether they are primates or not, or they are before even primates have originated. Because they seem to have some still mammalian-like features. So more of mammal, less of a primate they have. Maybe it's a bridge. Maybe this is where primate origins have started. But we don't know. But we're trying to find the beginning of primates here. So there is always a little bit of a confusion. Can you classify them as primates, or are they different order of the mammals? This is what you notice here. So some people said they have many primitive mammalian-like features. Like they have claws, no nails. They have rodent-like jaws and teeth, eyes are present on the sides of the head, so no stereoscopic vision. Okay, and change. They still have long snout, and they have what is called post-orbital bar, a type of skeletal or bony structure. So many mammalian-like features are still seen in them. Okay, so this is brief information about the this is from the Paleocene. What do you notice here? Bits and pieces of information that we have here. Okay, some terms that we talked about here were, infra-orders and families names that we talked about. But this is the beginning of the primate era. Okay, so later they have attempted to understand a few of these components, like in Plesiadiformes, for example. They were definitely different from prosimians and anthropoidea. Okay, so the debate was ongoing whether they are mammals or primates. Then we got some information related to Eocene, primates that were found in Eocene epoch. Eocene epoch. After Paleocene, Eocene epoch. This is where we got a little bit of more knowledge and information related to primates.
Do we need to remember the names of these primates?
And the exam point of view, no. But assuming that if they give questions in the exam, we have to list some of these names, unfortunately. Because what we know is what existed in Eocene, what existed in Miocene. Okay, so these names we have to mention in case if it happens to come in the exam, but so far we have not seen in the exam. So this is perfect, like little bit more information than what we need. Eocene, what type of primates were there? What are the specific families of them? What are their features? In theory, we have to be able to explain so much. So far we talked about the Paleocene where they're more like mammals, less like primates. Stereoscopic vision was not developed. Dentition pattern was slightly changed. This is what we have seen in the Paleocene. Now in the Eocene epoch.
The primates are also mammals, right? Like,
Primates are also mammals, but I'm talking about not the order of primates. Primates are more specialized mammals, right? We belong to mammalia, more specialized. So the order of primate, has it started or not, is a question. We don't have enough evidences to say. So next, Eocene. So here definitely there are few evidences that showed more primate-like features. So several evidences here from various studies from various areas represented maximum warming during Cenozoic era. The Eocene period also warming, climates were more warmer. So the temperature has increased here. So, and they're often, so the primates that are found in the Eocene era are called euprimates, or they are known as true primates. So true primates have started from Eocene era. Although their signs were there in the Paleocene, so hence they are called euprimates or true primates. So they resemble today's or modern day primates in various different features. Such as, so what features they have? You can write here if you want to make it easy. Eocene. Eocene had warmer climates, most warmer of this era, they say. Okay, maximum warming conditions of Cenozoic era. And this is where we have evidences for what is called euprimates. You mentioned euprimates. We have evidences for euprimates or true primates. Why do we call them true primates? Because they have a lot of resemblance with the current day primates. So features were obvious. They were becoming relatable to primates here. So what are the features of euprimates? Okay, they have forwardly facing orbits. So eye orbits came forward. So stereoscopic vision had begun. So forwardly facing or frontation of eyes, you can use the word if that is simple for you. Frontation of eyes had begun. Or forwardly facing orbits. Post-orbital bar, as I was telling you, before the orbit, there is a kind of a bony structure seems to have present in this post-orbital bar they call. Okay, or more, some features that you already know very well is opposable first toe. Feet have opposable toe. Okay, very much like how our arms are. Feet has opposable toes. That we talked about arboreal lifestyle, suitable for arboreal lifestyle, and grasping hands and feet. So these three features, if you want to write down: frontation of eyes, opposable first toe, grasping hands and feet. So these three features were evident in the Eocene primates. Okay, so this Eocene primates are divided into two major families. So what are the major families that are found in Eocene primates or the few primates? The two families are Adapidae and Homomidae. Adapidae, Homomidae. So what do you write? Euprimates or Eocene primates, write two major families. Adapidae and Homomidae. Homomidae. So Adapidae family showed creatures that were more like lemurs. We talked about lemurs, tarsiers in the classification. So lemur-like creatures were part of Adapidae. So lemur-like creatures were part of Adapidae, and they were mostly inhabited North America, Europe, and Asia. So they were more like lemurs that we talked in the previous class, or the class before that, and they mostly found living in North America, Europe, and Asia. So the currently we have lemurs, but these were lemur-like, so they got extincted. Whereas Homomidae was more like tarsiers. So these creatures were tarsier-like. The previous one was like lemur-like. These are tarsiers-like. And they have other subfamilies within them. Okay, I don't know if you want or you can leave it. So they have further, the Adapidae was further subclassified into Nothocretinae and Adapinae. So you can skip that. And Homomioids also categorized into subfamilies. Homomine and Anaptomorphinae and Microrinae. Microcorinae. So like that, usually the problem with this is different subfamilies and families are put together. Okay, so these are the two families that we have talked about here. And also we have some features related to them. Like for example, Adapid seems to have a dental formula of 2143. So which is more like primates. Okay, 2143 dental formula. Okay, so these are more primitive. So primitive dental traits like primates can be seen here. And Adapids mostly contained diurnal, so daytime living creatures, daytime active creatures. They found Adapids mostly contained diurnal ones with pattern of activity like vertical clinging, leaping. In the locomotory behavior we talked about yesterday, vertical clinging, okay, and leaping behavior can be seen from the skeletal parts. This could be predicted. So they are vertical clingers and leapers with more primitive dental traits, and others that they are diurnal, daytime active features, and vertical clinging and leaping motion. These are the characteristics of Adapids in addition to what I was telling you here with respect to Adapids. Okay, lemur-like features and their area, North America and Europe and Asia. And these are some of the features that we have seen in them. Whereas Homomoids were slightly different. They had a dental formula of 2133. Dental formula of 2133. So 2143 for Adapids, 2133. Basically, premolars were only 3, premolars here were 4. So number of premolars were different in the quarter of the jaw, in the dentition part. And these were nocturnal. The adapids were diurnal, these are nocturnal. So night time, basically they lived in night time, they were active in night time. Okay, and also they briefly discussed here how they are related to the more evolved primates. They talked about especially adapids were probably ancestors to the modern day tooth-combed primates. Some primates actually have comb-like structure. Okay, within the jaw, the teeth were actually organized in a form of a comb. So such type of combed primates are called tooth-combed primates. So adapidae were similar to the tooth comb. They didn't have tooth combs themselves, but they were like them. So meaning they probably eventually gave rise to the tooth comb primates. So they were probably ancestors to them. Whereas homomyiformes were mostly like tarsiers. So other living primates that we talked about in the last session. So tarsiers, they were similar to this. And this homomyiforms, they're more like haplorhini category of this division because we talked about streptorhini and haplorhini. So they were more like haplorhini. They're more similar to the haplorhini categories of primates. Okay, right. So this is briefly about the primates that we have seen in the Eocene period. So what did we learn here? In Eocene period, some more primate-like characteristics could be seen. This is where true primates or euprimates were found with several features like primates. Okay, and then here we talked about Adapidae and Homomidae, and within the Adapidae and Homomidae families, there were several subfamilies that were there. But basically, the idea is they had features like some of the primitive primates. Okay, but dental formula was not well evolved yet, but we had categories of diurnal and nocturnal living forms and creatures, more like lemurs and tarsiers were found there, and some of these were more like the modern day tooth-combed primates. Okay, this is what they could find in the Eocene period. Next, we'll move on to the tertiary fossils in the Oligocene primates or Oligocene period. Paleocene, Eocene we finished, we are going with the Oligocene. So Oligocene, Eocene to Oligocene have happened around approximately 34 million to 23 million years ago. Okay, lot of continuation in changes have happened. Geographical, climate changes as well as habitats of the primates have also changed. And it was noticed that majority of the mammals starting to extinct. Old form of mammals were going off and the new form of mammals were coming at this time, or there was an evidence for that. Okay. In the Oligocene periods, the fossil primates that were discovered were mostly anthropoids. Remember, from the previously we talked about kind of prosimians. From the classification, if you remember, they are more primitive type of monkeys. Till Eocene, we talked about more prosimian type of monkeys. But here now we started seeing the anthropoid, meaning more old world, new world, ape-like, human-like. Creation had begun in Oligocene area, in Oligocene epoch. Okay, the transition, so this is called Grand Coupure or Great Break in Continuity, where mammals got extincted. And key point you have to write here, the primate fossils that they found here are anthropoids. They were anthropoids. And by then looks like the euprimates we talked about from Eocene epoch seem to have extincted. So those are gone. Those from the Eocene epoch were gone. Now what we notice in the Oligocene period is anthropoids. So old world, new world, monkeys, etc. So this Oligocene primates or anthropoids here, already we talked about taxonomic groups here, haplorhini. They can be placed under Haptorhini, which are Parapithecidae, Pliopithecidae, and Platyrhini. Platyrhini, Haplorhini, we already talked about it, Old World and New World monkeys. Within them, so we have seen the evolution in that in Oligocene era. So especially suborders called Parapithecidae, Pliopithecidae, and Platyrhini. So within the Parapithecidae, they found the smallest anthropoid called Quaternary. Smallest anthropoid called Quaternary. This is where fossil evidences were obtained from a place called Fayum. So Cairo in Egypt. Fayum deposits or Cairo in Egypt, where they found some of the fossils related to the smallest anthropoid called Quaternary. Quaternary. This is a fossil that were obtained from which they could derive some features. They still contained, so within them, if you see within Parapithecidae, few features if you write down, they still have the primitive dental formula, 2133, primitive dental formula. Primitive dental formula still there. Okay, carrying third premolars. Third premolar was there, which is the one of the feature of platyrhines. Those that have flat faces, platyrhines or New World monkeys we call them. Okay, what else is important for you to make a note here? So they are showing more resemblance to New World monkeys. So that is why platyrhines. So dental formula was there. If you see the cranial features of them, they were more like New World monkeys. They were more like New World monkeys. Okay. And then the another one, we talked about briefly Parapithecidae. Parapithecidae has primitive dental features. They are more like New World monkeys. Then Pliopithecidae. We also have another family called a suborder called Pliopithecidae. The Pliopithecidae member seems to be larger. They are bigger than the members of Parapithecids. And these are larger and they are more ape-like. They started showing ape-like features, meaning they are more like old world monkeys. What do you see here? Some new world monkey creatures, some old world monkey creatures can be seen here. Okay. So Pliopithecidae shows ape-like features and they have features of the old world monkeys. Okay. So they had some features like old world monkeys. So it means that they probably would have given rise to old world monkeys. They may be ape-like and old world monkey-like splitting might have happened after that. That is why they carry features of both apes as well as old world monkeys. So there probably was a point that they survived before there was a divergence between old world monkeys and the apes. Okay, and some of these evidences, fossil evidences, showed features like gibbons. In the apes, within the apes, they shared features like gibbons. Okay, especially when they talk about the jaws that were found, an incomplete lower jaw they found as an evidence. It indicated that it has more gibbon-like feature, a gibbon-like face. So they can be considered as ancestors of the modern day gibbons. But there's still debate whether they are the modern ones or they also found, I think I was not sure whether I mentioned to you here. Here. So they found Egyptopithecus. one of the largest phaeum primate they found. So some scientists or archaeologists have thought that they probably are more of the ancestors, more like ancestors to the modern gibbons. Modern gibbons. Okay, but what are we learning here? In this period, in Oligocene period, there were clearly those with the primate-like features, with several taxonomic groups that were placed on them, like Parapithecidae, Propliopithecidae, Platyrrhini, some old world monkey-like, new world monkey-like, ape-like creatures who existed during this time. So we see it here, right? Mammal-like, somewhat primate-like. From there we move like true primate-like. And from true primate-like we are moving to more ape-like and more new world monkey-like, old world monkey. So they were evolving to what we see today, right? Then we move on to Miocene and Pliocene. Usually they say that Miocene, Pliocene is very difficult to distinguish. I think the layers got mixed up, they say. So they could not clearly say whether it belongs to Miocene or Pliocene. So in the literature, they normally talk about Miocene and Pliocene together. Miocene and Pliocene primates. Okay, because there was continuity of certain lineages of Anthropoidea, so they were usually considered together. Both of the epochs are examined together and considered together. So here they found several fossil remains of hominoids. So we are becoming more human-like here. They found many hominoids here. Okay, like they call Cebidae, Sarcopithecidae, Laurisidae. So remainings that were like Cebidae, Sarcopithecidae, Laurisidae were found in this period. Okay, this is I think partly some of these you might have studied. So they are mostly found in Asia, Europe, and Africa. These evidences were found or obtained from Asia, Europe, and Africa for Miocene and Pliocene primates. I'm not sure if you studied them. In unit paper 2, have you studied about Ramapithecus, Shivapithecus? Have you learned about, is that part done? Ramapithecus and Shivapithecus part is done from fossils. Paper 2.
No, sir. No, sir.
No, okay. So these normally covered under that. So what are here? We're talking about, I'll give you the features of them here. So in the Miocene and Pliocene primates, they would find hominoid forms like Dryopithecus. These are the main names you have to write. Dryopithecus. They found in Spain. Hominoid forms, Dryopithecus. And they found Oreopithecus and Auranopithecus. So whenever we are using the words Pithecus, so they already have characteristics of apes. So the ape-like features. That is why we use the word Pithecus as a suffix. Dryopithecus, Oreopithecus, Auranopithecus, Shivapithecus, found in Pakistan. Shivapithecus. And Kenyapithecus, found in Africa. Kenyapithecus. Okay. So these type of Dryopithecus, Shivapithecus, Oreopithecus, and Auranopithecus, and Kenyapithecus are some of the evidences of primates that we found in the Miocene and Pliocene periods. Okay, and these hominoids have a lot of resemblances with respect to the primates. Some of them are quadrupedal climbers and walkers. So they were using 4 feet to climb and walk. So ape-like features. But some forms may have also employed suspensory activities. Okay, so we have talked about this quadrupedal and features of them in the locomotion, right? So their quadrupedal features could be seen. Along with that, they also had some other features like suspensory activities in the process of movement. But definitely quadrupedal features were more like the ape-like features you could find in them. And also there was sexual dimorphism. So males and females can be distinguished from each other. The dimorphism has arisen in the males and females. Clear cut differences in genders could be seen here. Okay, like large monkeys to small gorillas, those type of resemblance that could be found here. And within them, I think they have given enough here. Within them, we can see that Pliopithecus, which were deposits found in the Europe. Okay, especially mandible part was mostly seen here, found here. So it had resemblance with gibbons. So previously we talked about gibbon-like features, right? So here they have a lot of similarities, resemblances with the gibbon, with the characteristics like wide set eyes and a narrow snout. So facial changes. So widely placed eyes, ape features, widely placed eyes and narrow snout that was seen but narrow. So they found Pliopithecus fossils here, which have resemblance to the gibbon-like features like wide set eyes, narrow snout. And then they found Dryopithecus. So ape-like, Dryopithecus, ape-like primates. And what they found were mostly some teeth and jaw bones during the excavations related to that. Okay, and some of these Dryopithecus ones were found in Europe as well as in the Shivalik hills of India. Ramapithecus, Dryopithecus you study in paper 2. Fossils found in India, these are some of those fossils you would study in that. And in the exam, usually Ramapithecus shows up. Ramapithecus, Narmada man, you have that in the syllabus, they usually show up in the exam. Dryopithecus, some of the fossils found in Europe, some found in Shivalik hills of India. And this Dryopithecus is considered to be the ancestor of modern Pongidae. Pongidae means the category where gorillas and chimpanzees are placed. So Dryopithecus has features like gorillas and chimpanzees. So Dryopithecus has shown features like gorillas and chimpanzees. Especially, they say, the dentition pattern, the cusps of the lower molar teeth. If you see the upper side of the teeth, you will see cusp-like pattern. Sometimes you see Y-like pattern, 5 cusps, they say. So within the teeth, if you actually touch the surface of the teeth, you will find there is specific type of surface layers that you find. Okay, some sharp regions and the flat regions that you will find. So this is called cusp region, the top portion of the teeth. Okay, and they can actually see how many corners are there to that. So this cusps actually show Y5 arrangement. So let's show the image here. So what happens? They have 5 corners like this and Y shaped. You can draw a Y in between that. That is how they are arranged. So they're talking about specific feature of the teeth, the cusps of the teeth, especially on the lower molar teeth. They show Y-5, 5 such corners with Y-shaped structure in the middle. Okay, so this is called Dryopithecus. So ape-like, modern gorilla-like, and chimpanzee-like with the dental pattern-like. Okay, like these Pongidae members. Then proconsul. At that time, they also found the proconsul. So proconsul, in a way, you can say it is a Dryopithecus of Africa. Previously, we have seen Dryopithecus of Asia and Europe. So proconsul is more like the African version of the Dryopithecus. So they found in Kenya. So African Dryopithecus, you can say. Then Ramapithecus. Ramapithecus. Okay, Ramapithecus. So what is Ramapithecus? So Ramapithecus was a hominid. Okay, it is described as a hominid, and this was found in again Shivalik hills of India. So fossils for Ramapithecus was found in Shivalik hills of India and Kenya, Fort Turnan in Kenya. G. Lewis was the archaeologist who unearthed this in 1932 and discovered Ramapithecus in Shivalik hills. G. Lewis, 1932, discovered Ramapithecus in Shivalik hills of India. So they thought this Ramapithecus probably is one of the two genera. They thought both Ramapithecus and Dryopithecus are two different versions. Rama and Dryopithecus were two different versions. Okay, two different versions of genera, and he thought, or he explained, that Ramapithecus is the initial step in the divergence of humans from the common hominoid stock, meaning from the hominoids, modern apes and humans were developed, right? Maybe Ramapithecus was that point where just before humans and apes were created, maybe Ramapithecus was there, meaning it was ancestor to both apes and humans. So Ramapithecus was, so Pithecus, ape-like, right? So probably was part of the before divergence of humans and the apes. And they could see the dental features of this Ramapithecus being different from the Diopithecus. How? So incisors and canines have become smaller in Ramapithecus compared to Diopithecus. Diopithecus, what happened? Incisors as well as canines have reduced in terms of size. And the pattern, molar cusp pattern, that Wi-Fi shape pattern that we talked about, it is not present in the Ramapithecus. So incisor size and canine size are reduced in Ramapithecus, but the cusp pattern that what we discussed in Dryopithecus is not seen. And also they found Ramapithecus upper jaw, which showed that it is small, it is short, and the palate is also arched. Arched palate can be seen. Okay, so there are more man-like features, more human-like features can be seen compared to the Dryopithecus. So some changes, especially the jaw part, if you notice, is smaller, became smaller. The palate actually had become more arched, which are features of humans, the characteristics that we briefly talked about them, right? So there are more human-like features you can see in Ramapithecus. And also, they indicated that Ramapithecus probably erect biped with hands free. So maybe they started walking on 2 feet already. Maybe erect biped. Okay, could stand up, walk on 2 feet with hands free. So some people thought that Ramapithecus is maybe our likely ancestor of the Homo sapiens. Okay, it may be our ancestor, maybe humans' ancestors. There's a debate on this. So they say that human ancestors were there in India, but some scholars don't agree with this. But as per the Ramapithecus evidences that we have, we believe that it is an ancestor of Homo sapiens. And as per another scholar, Das, in 2008, who published this, he even said that Ramapithecus was separated from Dryopithecus lineage in the Miocene epoch itself. So maybe this Dryopithecus went in one direction, Ramapithecus went in another direction in evolution, not geographically, but in terms of evolution. So like that, Ramapithecus, more human-like evidences were found from India, okay, during this period. Okay. Similarly, there were others like Oreopithecus. I also heard Shivapithecus. Also, there is something called, it's not mentioned in this source, but there's something called Shivapithecus was also found. Shivapithecus. Okay, Shivapithecus also found in Shivalik hills of India and more with orangutan-like features. Shivapithecus, Ramapithecus and Shivapithecus. Orangutan, they have orangutan-like features. So these are some examples of fossils that were found. Fossils that were found in the Miocene and Pliocene epoch. Miocene and Pliocene epoch together. Okay. So next we move on to the Pleistocene or Quaternary period. So here we are moving from 1.5 to 1.6 unit. So here we're talking about Pleistocene epoch, Pleistocene. So which is part of Quaternary period, right? We talked about Quaternary as two epochs, Pleistocene and Holocene. Pleistocene and Holocene. Holocene is the most recent one, as I was telling you already. Pleisto and Holocene.
So,
Yes.
a new epoch was also in use Anthropocene.
What is it? Come again?
A new epoch was also in use Anthropocene.
Human, yeah.
We
So
should, since it is not formally established, so like we should write it or not.
you can mention it. You can mention as part of the Holocene. There is a discussion on proposing Anthropocene as well. You can make a mention of that.
Okay, sir.
Okay. Just give me 1 second. Right. So what do we learn in this quaternary period in 1.6? As I was briefly telling you, in unit 1.6, we are focusing on further evolution. So moving from the tertiary period, quaternary period, further uh, features related to humans have been established. So here in the syllabus, if you see 1.6, they talk about phylogenetic status, characteristics, and geographical distribution. So they're asking us to learn about phylogenetic status. So in evolution, where are they placed? What are the characteristics of them? And where are they distributed? Where are the evidences of their fossils found? For they have given 5 categories here. This is a continuation. 5 categories here. One, Pleistocene hominids in Southeast and Africa, South and East Africa. So specifically, we talk about Australopithecines, and then Homo erectus. We have to learn about within Homo erectus, those in Africa, those found in Europe, those found in Asia. We have to learn 3 examples of Homo erectus. And 1.6c, they're asking us to learn about Neanderthals. Neanderthals, within them, La Chapelle, classical type of Neanderthal, progressive type of Neanderthal, Mount Carmel, we have to learn about. And 1.6 the Rhodesian man, 1.6e Homo sapiens, within them, modern humans, Cro-Magnon, Grimaldi, Chancellidi. So basically, idea is this. In the 1.6, you keep learning about the progress to humans. What are our ancestral evidences? What are our ancestral human evidences? And we see slowly from ape features to human features will evolve. And certain examples are given. There are much more than this. In the literature, more than these that you find. But in the UPSC syllabus, only specific ones are given. What I'm going to do, I'm going to specifically go through the components of that. Today, we'll talk about Australopithecines, the first one, 1.6a, we'll talk about. But the concept is same. Specifically, what are they asking us to learn about? Phylogenetic status. How are they connected overall to the previous versions? And what are their characters? Where are they found? Is what they're asking us to learn. Where possible, I'm also going to add cultural aspects of them. What culture was present at that time? So we are moving from the 1.5 to 1.6. This is the bridge part. So we are moving to the quaternary part. Okay, as I was already telling you, quaternary period is where we have seen those two, particular epochs, and this had begun in 1.8 million years ago. This had begun 1.8 million years ago. So 18 lakh years ago. Basically, it started 18 lakhs years ago, and it is called the age of humans. The quaternary period is called age of humans. It's called age of humans. So quaternary period is a current period, as I was telling you. So within the quaternary period, the continents have not moved much because they slowly move. We don't realize that very much. The continents were almost the same, positioned the same, but climate has changed during the Quaternary period. Slow changes in the climates have happened in the Quaternary period. Okay, the first epoch in this is Pleistocene epoch, which goes from 1.8 million years to 11,000 years. 1.8 where Quaternary period begins, right? The first epoch is the Pleistocene epoch, goes up till 11,000 years ago. If you see these numbers, 11,000 seems to be very close, right? It looks like a small time space. 11,000 years, up to 11,000 Pleistocene, and Holocene followed by that, 11,000 to present. Okay, and Anthropocene seems to be the new epoch, which is, as Sweta was talking about, is not an official one. Okay, unofficial version. So where I think humans started impacting the climate, the concept of global warming, the ecosystem starting getting damaged. So I think this era they're proposing to name it as Anthropocene. Okay, so we may see soon Anthropocene epoch added to this. Okay, so otherwise we are in the Holocene epoch. Okay, so a rough picture overview I would like to give, because we'll talk about a lot of factual data, features, characteristics, which we kind of already discussed in race concept and applications of anthropology and forensic anthropology. Some of the features we discussed. So the terminology, the concept should not be too difficult for you. And also put into the context of how evolution is slowly proceeding. How evolution is slowly proceeding. So here you see that from, so if you see approximately 3.5 or 2.5 million years ago, if you notice that Australopithecus, hominids probably have originated. Hominids, very small, so more ape-like, okay, bipedals probably were created. They're called hominids, Australopithecus. From there, Homo habilis. So you see Homo genera has started. Homo refers to more man-like. Okay, so we were slowly seeing the evolution from more ape-like to human-like. So Homo habilis, basic idea. Features are more, again, evolving to look like more humans. And then Homo erectus. You see Homo erectus is holding the fire, where probably within his time, the fire has been invented. Homo erectus. And then came Homo neanderthalensis. Tools, various specialized tools were created. And then today, Homo sapiens sapiens. Humans who know their wise. Okay, some aspects of height has changed. 1.1 meters to 1.59, 1.6, 1.65. To the current day, humans approximately 1.7 meters or 1.7 meters. Weight has also changed. 40 kg to 50, 60, 80, and approximately 70. Bit of an adjustment from Neanderthals to us. Okay, so and already I think this Australopithecus people walked upright. Ramapithecus, we said, seems like having evidences that they were walking upright. Okay, and habilis already had some clues about tools. So first tools might have developed here, and maybe they were already started to talk, started to communicate. There were indications that they probably had enough developments in their brain, enough developments in their voice boxes, for example, which could allow them to talk. Okay, and then Homo erectus, I was telling you, discovery of fire. They started hunting in groups, which moved on to the Neanderthalensis, where burials, culture has begun, more like cultural components. Burials, special way of burying people, specialized tools were designed, improvisation from what Homo habilis was found, and to a level where we have now special form of culture, special form of art, various enough diversity in the tools, modern technologies, they all had come in Homo sapiens. Like that, slowly we are seeing our ancestral human. There's only some examples of our ancestors. So we are going to expand more on these features, more on these type of specific examples. Okay, this is to just to provide you a brief picture. Okay, we are going to give details. We are going to talk about details about Australopithecus. So this gradual evolution part we have to learn. Okay, and the challenge with this is remembering what features were there, what features were not there. This requires a bit of revisions. But first, let's figure out what it is, and then you can focus on this. Okay, can I move on? So this is a picture that should give you an idea about drawing things, drawing images. If you want, I'll share this in the group. So this helps you to make simple drawings of skulls, of teeth. Okay, so humans, more flat faces. How do you draw it? You can just follow this approach. You can put a bit of curvature here, more flat face, a little bit of a nose, and then more or less flatter jaws. Whereas here, what you notice, you have to have an angle. You have to draw an angle like this so that you are showing the prognathism. And also remember to show canines, big canines on the sides like this. This image I'll share in the group, Telegram channel. So this is a good image I found that where you can write. And also you can use this type of pattern if you want, teeth pattern. Molars, you write like this. Canine, you can write a big canine. Chimpanzees have these big canines and a lot of prognathism. Okay, and they were quadrupedal. They were walking on 4 feet. And then our ancestors, like Ardipithecus, Australopithecus, they already had bipedalism. And look at the canines. Canine was in between here, between chimpanzee and Australopithecines. And Australopithecus probably had a smaller canine, but relative to us, still bigger, but definitely smaller than what chimpanzees had. So you see gradual difference. Most of the times we talk in relative terms here. They gradually change. Homo erectus also bipedal, this, and no arboreal lifestyle, because till here chimpanzees can have arboreal life. Ardipithecus, Australopithecus also had some amount of living on trees. Well, later, as humans got evolved from it, like Homo erectus onwards, no arboreal life, mostly terrestrial life. Okay, so this is one idea where you can draw teeth like this, right? These skulls. So prognathism, canines, sloping, you know, um, foreheads, flat foreheads for this, lopping foreheads for this, and brow ridges. You see brow ridge. If you want to show the brow ridge, absence of brow ridge in us, we don't have. It is more or less like flat, but here they have big brow ridges like this, protruding out, protruding brow ridges. Okay, these are just hints to draw something. Okay, right. This is also something I'm going to share with you, because this is all to provide the overall picture of things. Okay, so Australopithecus started there. The timeline of hominids. So millions of years. approximately started with 10 million years, 9 million years, etc. So this is where apes were there, gorilla-like separation probably what happened. Okay, chimpanzees got evolved probably from this period. So the one we are interested is after this chimpanzees, Ardipithecus I mentioned, not in the syllabus of course, Australopithecus. Between this 4 and 3 million years, probably Australopithecus has started. So bipedalism, earliest bipedalism might have started before Australopithecus because Australopithecus is already bipedal. So probably bipedalism has started here. And stone tools, as I was already showing you, might have started after Australopithecus, like in the Homo habilis time. And Homo habilis is not in the syllabus, but this is something a really key one I have seen. I might give you a few features of Homo habilis. And after Homo habilis during Homo erectus time, that is between 2 to 1 million years, 2 to 1 million years approximately, where we might have found the earliest fire use. I was showing you this Homo erectus, earliest fire use. And also probably at the Homo erectus time, people might have moved to the other continents. We'll study about out of Africa theory, where they might have started moving from Africa to the other continents. Earliest exit from Africa. So this supports the concept of out of Africa theory that we're going to learn in tomorrow's class. And then Heidelbergensis, Homo heidelbergensis, cooking, clothing, other forms of culture, burials, we talked about those kind of stuff here. And led to the modern speech, modern languages, etc. between Neanderthals and Homo sapiens. Okay, these two images will give you a broader view. But as I give more details to you, there is a more informative image I have with me that I'm going to share. This is the beginning. I would like to show something simple like this. They are the periods, approximate locations, where they were found. I have a more complete image on this. So towards the end, when I summarize things, I will show you that. So it will become easy for you to remember and revise the information we learn here. Okay, right. Let's start with the first example, Australopithecines. So quickly, I think most of the terms you probably know here. So Australopithecines, as I've shown in the timeline. So Pithecines means still ape-like. Ape-like. Australo means south, ape. Southern ape it is called. Excuse me. Southern ape. Excuse me. So these Australopithecines had features with the brains like chimpanzees. Brain size was like chimpanzees' brain size. But remember, in the image I was showing you, they are smaller. Australopithecines were shorter compared to us. Shorter, brain size is as big as chimpanzees. And they still have long arms, like apes. We're talking about ape characteristics, right? Compared to humans, they still have long arms. So Australopithecines still are ape-like. They have long arms. And there are evidences that they probably have human-like footprints. Their footprints are there, and they look like human-like footprints. So meaning they probably already bipedals. In the image previously I was showing you that bipedalism might have started before them, right? So the footprints are more human-like and they were bipedals. And their canine teeth I was showing in the image before is becoming smaller. It's still not as small as what we find in us, but it is smaller than chimpanzees. Smaller canine teeth relative term. Okay, I'm going to share the content on this, features on this. I want you to focus on what are we learning here. So here basically talking about more ape-like features in Australopithecines, but this is the first category in 1.6. So brains like size of chimpanzees, shorter, long arms, footprints like humans, and smaller canines. The key features we learned here. Okay. So this is a footprint. You can clearly see how toe was. In Tanzania, they found footprint trail of 3.5 million years old. Probably people walked like this, and their footprints were there. Okay, some form of Australopithecus. There are different species of them. Apharensis, one of them, but Australopithecines probably walked like this. And location, geographically, where are these fossils found? This is factual data where the fossils were found. Fossils were found in South Africa. In South Africa. So here is a list of those fossils. List of those fossils. This will be part of your handout, okay? So place, different places in South Africa like Tong and Kromdraai, okay? And Makapan Sangat, Sterkofontein, and Swartekrans. These are the places names. You mentioned a couple of them. You don't have to by heart some of them, by heart all of them. Some of them. Tong, for example, Tong child is common name. So Australopithecus africanus was found here. So different fossils, they have specific names, genera and species names you see here. Australopithecus africanus, Australopithecus promethicus, and different genera you'll find here. Paranthropus, I'm going to explain that briefly. Paranthropus. Okay. And these are all discovered between 25 to 48, 1925 to 1948 by mostly, you will find here Robert Broom was the one who contributed mostly to it, and Raymond Dart are the scholars who discovered them, archaeologists who discovered them. Okay, I think mentioning one or two of them when you are writing a short note on Australopithecines is enough. Okay, in the nature of the questions that you basically see, so short notes are coming. For some specific information is asked, I'm going to cover that in the next class. But otherwise, mostly Homo erectus. Yes, we had once question on Australopithecines, phylogenetic position of Australopithecines. Otherwise, Neanderthal, Rhodesian, Homo erectus. Okay, was asked in the exam. Homo habilis they asked once, also not, although not in the syllabus, they asked habilis once. Okay, like that also, East Africa, they found some fossils related to this. Hadar in eastern Ethiopia and Omo in southern Ethiopia. In Ethiopia, they found fossils related to Australopithecus afarensis. This is very famous, Lucy. Sometimes appears in the news, Lucy, they call it. So Lucy, they found Australopithecus afarensis it is by Johansson in 1974. Otherwise, in southern Ethiopia also, they found a lot of them. Africanus, Boise, Habilis, Erectus. Okay, Louis Leakey and Olduvai George, they unearthed this. So what do you learn? They show that their presence mostly in Africa. So they were probably there only in Africa. That is why theories have emerged where we started seeing other fossils being distributed later somewhere else. So meaning this was indicating that they were probably present or limited to those regions in Africa. That is why out of Africa theory follow these type of evidences. Okay. So in the material, I'm also going to briefly compare these two things. In Australopithecines, okay, two species they talk about, Australopithecus africanus and Australopithecus robustus, they talk about. Or sometimes we have seen the word Paranthropus, right? Paranthropus refers to one form of Australopithecus. So basically, they could find a different overall body build. So Australopithecus africanus are more slender built and small versions. Paranthropus is the more robust version, big versions. So size-wise, there seems to be a difference. So they categorize them into two species, Australopithecus africanus, Australopithecus robustus. Okay, within these two species, you can give examples like this. Lucy, we talked about Lucy. Lucy, they had found most of the skeletal parts. As you see, some of them were missing. They could find majority of the skull, majority of the region here, rib cage, for example, and arms, some limbs portions. Based on that, they derived this information. The height they could derive, 1.1 meters, so short. That is why they say they are short. They were also weighing less, 30 kgs. Prediction was 30 kgs. But they were having good amount of muscular strength. Limb bones are dense, so enough muscular strength that they could predict. The limb bones have more density. And from the skull, they could see that the face has a lot of prognathism. So ape-like face, a receding forehead, and the brow ridges, okay, were protruding. And nose was becoming flat, more monkey-like. We were seeing that platyrrhini-like features. And chin was not developed. For that chin, this jawbone has to decrease, has to reduce in size. Then chin will become prominent. So in this case, it is still ape-like. So majority of the features that we are seeing here, I'm also going to put this in the handout. Okay, information like this. So what we know from Lucy, one of the evidences that we have, the height of it, weight of it, and maybe strong bones, especially in the limb bones, and ape-like face. So this is how they derive. So you can say, as per the Lucy, evidences obtained from Lucy's fossil, these are the following features of Australopithecus afarensis. So small or a short version, as I was telling you. Okay. Write down the only keywords. I was telling you, shorter, 0.1 meters, less heavier, 30 kgs, strong limb bones, ape-like features. Those are the key points you have to write. Remaining details you will find in the resource I'm going to give you. The structure is enough. Hope you're not trying to draw this, right? Just joking. Okay. Okay, so we'll take an example of, so affarensis, more or less the same story, but I think Lucy is a better evidence. So we'll skip this. Otherwise, we're talking about majority of the features. 8 features we talked about: sloping forehead, head size is small, like this. They have about 400 cc head size. Okay, and brow ridges are, I was already talking to you about. What else you need? Femur slanted towards the knee. So curvature in the femur can be seen here, bipedalism. Arched feet with wide heels. Big toes, so aligned with the other things. So these are changes in bipedalism that we discussed already. Okay. Long and curved fingers and toe bones. So majority of these features, some ape-like, some human-like features you can definitely see. Face is mostly ape-like, limbs are mostly like human-like, and arms are also mostly human-like, can be seen. Okay. So the robust version, if you see the robust version, okay, the other bigger version of the Africanus I was telling you about, or Anthropos I was talking about. So Australopithecines I was talking about. So skulls were round. Some of the skulls they were found related to this. Okay, they were round, and sometimes you hear what is called sagittal crest. So if you talk about Paranthropus, they have sagittal crest, meaning a muscular structure here on the top. If you see this sagittal crest here, it means that they were chewing. They were actually having a lot of chewing activity. because strong muscles will create this sagittal crest part. Okay, so it's like a ridge of the bone that you find here where chewing muscles are connected. So they probably were chewing a lot of vegetables here. These are all predictions on the diet. Lower jaw is really, really massive. The mandible is very massive, it's huge. Face is becoming bit flatter compared to the other apes, bit flatter. But they still have huge cheekbones or zygomatic arch, huge cheekbones. Okay, so these bones were huge. And the lower jaw mandible was big, so no chin. Okay, and sagittal crest. Okay, we'll stop the class here. So tomorrow I'm going to talk to you mostly about the phylogenetic position of Australopithecines. We are going to talk about here. I need to explain more. So we don't have enough time today. I'm going to do that tomorrow, and we'll talk about culture, and we'll move on to Homo habilis and the rest. My aim is to finish off the remaining things like Erectus, Neanderthal, Rhodesian. It's mostly like this. What I have to tell you is show you the content, explain the features and key points, geographical locations, anything known about culture related to them. In phylogenetic tree, I explain it once. So using that, you can explain for whatever example that they ask for. I'll show phylogenetic tree for all of them once. What is it? How is it made? What is the importance of it? Okay, so let's see. If even needed, I'll take a bit longer session tomorrow and wind up this 1.6 part. But we got a picture, we got the structure. We have to fill the information into it. Okay, is that good?
Yes, sir.
Okay, so right, guys. Thank you. I'll share the content with you and you get a chance to go through it.
Sir,
Okay.